Problem number 37, find arc length parametrization for r of t is 3t plus 1, 4t minus 5, and 2t. So the first steps that we do here is that we need to calculate out r prime of t and the magnitude of r prime of t. So r prime of t here, the derivative is 3, 4, and 2. And so the magnitude of this is just 3 squared plus 4 squared plus 2 squared, and that's the square root of 29. And so note in particular here, this is a constant. This has constant speed. The speed is square root 29. So to find s, the arc length parameter, we integrate from 0 to t of the speed, square root of 29. We need to use some letter there, like du, d tau, something like that. And this then will be square root of 29t. So s is equal to square root of 29t. And then the last thing that we have to do here, I guess there's two more things we have to do here. We have s in terms of t. We want t in terms of s. T is equal to s over the square root of 29. And so to find our arc length parametrization, what we do is that we take this and we substitute in t is s over square root 29 here. So our arc length parametrization in terms of s is 3 times s over square root 29 plus 1, 4 times s over square root 29 minus 5, and 2 times s over square root 29. And if you check for yourself, this is going to parameterize the same line. This happens to be a line, and this parametrization will have speed always equal to 1. Okay, problem 38, the very last problem of this worksheet. Hopefully you've benefited from these videos. The acceleration of a particle in the plane is a is 2t I hat plus 8j hat. So first thing is we need to find the particle's position of function of t. We're told that v of 0 is I hat minus j hat, and the position at time t is equal to 0. So that's r of 0 is 2i hat plus 3j hat. Okay, so how do we answer this? So this right here, this is the derivative of velocity. So we integrate a here to get velocity. We would get t squared times I hat plus 8t times j hat. But then we need to throw in constants here, the constants of integration. Now the thing is that when we plug in 0, we get 0 squared plus c1 I hat plus 0 plus c2 j hat, and we want this to equal I hat minus j hat. So guess what? c1 is 1, c2 is negative 1. And so v of t is actually t squared plus 1 I hat plus 8t minus 1 j hat. Okay, so that's our first integration. We need to do a second integration to get back to position. Okay, so r of t, because of course this is r prime of t, so we integrate one more time. We'd end up with t's cubed over 3 plus t times I hat plus 4t squared minus t j hat. Once again, we need more constants. Let me use c3 and c4 here. And if we plug in 0 cubed over 3 plus 0 plus c3 I hat plus 4 times 0 squared minus 0 plus C4 j hat here. And we want this to equal, from our initial condition, 2I hat plus 3j hat. So C3 is 2 and C4 is 3. So this makes our final R of 0, oops, not R of 0. This makes our R of t equal to t cubed over 3 plus t plus 2 times I hat plus 4t squared minus t plus 3j hat. So that is part A here. A couple integrations, initial value problem. Part B says find the speed of the particle at time t is equal to 1. Well, speed, well, first we need the velocity at time t is equal to 1. V of 1 is, plug in right here, 1 squared plus 1 is 2I hat plus 8 times 1 minus 1 is 7j hat. So the speed at 1 is the magnitude of this. Square root of 2 squared plus 7 squared, square root of 53. So yeah, this completes the video sets. Hopefully you've enjoyed them. Good luck studying, good luck taking the test. My hat is off to you. You made it through all of these videos. Good job.